Hello everyone and welcome to my presentation. My name is Vedant Darawade, mechanical engineering student at Patil College of Engineering, Akurdi. I am from Division B, roll number 35. Today I will be presenting on engineering thermodynamics, covering fundamental concepts and energy interactions. Let's begin with the basics. Thermodynamics is the branch of physics dealing with relationship between heat and other form of energy. It describes how thermal energy is converted to and from work and how it affects the matter. The core interaction can be summarized as internal energy interacting with the heat and work. To study thermodynamic processes, we define three basic terms. The system, the specific quantity of matter or region in space chosen for study. Boundary, the real or imaginary surface separating the system from its surroundings. Surroundings, everything outside the system boundary. Talking about defining limits, boundaries can be fixed or moving, real or imaginary. Correctly identifying the boundary is critical for calculating the energy flow. A fundamental rule to remember is system plus surrounding is equal to universe. Moving ahead, temperature, heat and work. Temperature measures average kinetic energy of particles within a substance. Heat and work are the modes of energy transfer that occurs between system and its surroundings. Energy transfer in two primary modes. Heat flow, energy transfer driven strictly by a temperature difference. Work interaction, energy transfer associated with a force acting through a distance such as a moving piston or shaft rotation in cyclic system. Now, looking at a temperature measurement, the constant volume gas thermometer uses the pressure of gas to determine the temperature. By keeping the volume constant, adjusting mercury levels, pressure changes proportionally with the temperature. Following the ideal gas law, where P is directly proportional to temperature. Comparing the different thermometer types. Constant volume gas thermometer. It uses the pressure and serves at high precision primary standards. Residence thermometer RTD. Use electrical resistance R for stable industrial accuracy. Thermocouples use voltage EMF for fast response across wide range. Then the first law of thermodynamics. The first law of thermodynamics states the principle of energy conservation. Energy can neither be created nor destroyed. It can only be transformed. Mathematically, delta U is equal to Q minus W. This means the net internal energy change equals heat added minus the work done by the system. Going ahead, heat and work interaction. Here we observe the trend analysis of work interaction versus the heat dissipation in cyclic engines over time. As process intensity progresses, energy levels fluctuate continuously as work is converted and heat is dissipated throughout the operational cycle. Finally, we have the total energy accountability. 100% of the energy entering as heat or work is accounted for the internal energy change, delta U. Our sign conversion are plus Q for heat added to the system and plus W for work done by the system. Thank you.